Alrighty, so I'm going to be going over the Chinese remainder theorem and one example of how to derive it. So what is the Chinese remainder theorem, also known as the CRT? Well, what it basically says is that if you have something, or you want to find a number that is both A mod P and B in mod Q, given that P and Q are relatively prime, then there exists one answer, C in mod PQ. So there exists only one answer. Now the question is, let me rewrite this B. The question is, how do we find that C? So that's what I'm going to be going over right now. So let's think about it a little bit. What if we had a number that was 1 mod P, but 0 mod Q? So again, here we go, 1 mod P, but 0 mod Q. And if we had this number, then what we could do is we could multiply stuff into this, like say, for example, A, and we would be able to fine tune the placements of this number in mod P, but because we have 0 mod Q, however we multiply it or whatever, it wouldn't affect its placement in mod Q, right? So that's kind of what we're aiming for here. We want something with 1 mod P and 0 mod Q, so we can fine tune our placement in mod P while not touching our placement in mod Q. Okay, so let's do a little brainstorming and try and think of a number that would satisfy both of these. So let's do the 0 mod Q one first. That looks pretty easy, right? I mean, what's a number that's 0 mod Q? Well, Q is 0 mod Q, right? So now we have Q. Now the question is, how do we get Q to be 1 mod P? Well, I mean, that's what inverses are for, right? So if we multiply Q by Q inverse in mod P, then what happens is this is going to become 1 mod P. Well, it's also still 0 mod Q because it is a multiple of Q, right? So now we have this. What we can do is we can multiply A into the whole thing, and then now this length right here is going to satisfy our condition with 1 mod P and 0 mod Q, and we multiply it by A, and then that's going to satisfy A mod P right here. Okay, so we're going to do kind of the same deal with B. So again, we're going to find something that is 0 mod P, but 1 mod Q. And of course, the way we would do that, we start with P, and then we multiply that by P inverse in mod Q. And then this total together is going to be 1 in mod Q. And then, of course, we just multiply B into this whole shebang. And then once that happens, we just add these two solutions together. So if we want to find a number that is A mod P and B mod Q in mod of P times Q, to find C, our C is going to be equal to A times Q. A times Q inverse in mod P plus B times P, times P inverse in mod Q. And this should be our C. And again, the main point that we're going to be looking for is to have something that's 0 mod Q and 1 mod P. So like we can fine tune our position in P and not worry about anything in Q. And then also at the same time, we want something that is 0 mod P and 1 mod Q, so we can fine tune our position in Q to B and fine tune our position into A. Right. So there you go. This right here should be our formula for finding C in the Chinese remainder theorem.